It's really nice to be here at such a sort of back to basics conference. It's been a while. Kudos to Pandia for sorting it. I'm just here to give you a quick progress report on what we've been doing at Parity. So if you're not familiar, Parity is a Ethereum client. It connects to the network. It does all the stuff that you might want a client to do. It's written in Rust, which is notably modern language with certain correctness guarantees. And it's got a nice sort of actor-based architecture, which gives it some degree of reliability. It's got a bunch of advanced features, including state tree pruning to keep the database size down, automatic upgrading using a particular smart contract, which I'll go into a bit later, light client operation coming in soon, has consensus abstraction and chain specification files so that we can actually alter which consensus mechanism we use. We can develop new ones. And I think Peter was chatting a little bit about that at the end of yesterday. Some of our work in there, I'll go over that a little bit as well in this presentation. So the first thing is the PAR protocol, which we've been pushing. This is a new wire protocol. I believe that the guys from Ethereum J have also been starting to implement this. Is that, anyone confirm that? Okay. It's what powers the warp sync stuff, so you can actually sync the mainnet network in about a minute if you've got a decent internet connection. It's got, we actually built multi-level security into this so that it doesn't do any of the really sensitive stuff until it's fully synchronized with the previous receipts and transactions, so it can guarantee a full chains proof of work. Our new protocol, our new wire protocol is called PIP. Parity Light Client Protocol. This builds on some of the work that the foundation teams have been doing, the LES protocol. It adds a few optimizations and some extra message types for managing some of the more sort of additional stuff that we want to do with the light client. Next thing we've been doing is vaults. This is basically to correct one of the sort of minor niggles of wallets, of Ethereum wallet files. They include the address in plain text, which basically means if anyone gets access to your home directory, they can see which accounts that you control. It's far from ideal. The original wallet spec actually didn't have the address in plain text in it. It was an extension from one of the major clients. We now encrypt this, the metadata, so the address and any other information concerning the account. One password to decrypt it per directory, so basically all your wallet files in the same directory are encrypted. The same, the metadata itself, that said, is encrypted with the same password. And you can have different paths, so you can have different vaults, as they're called. You might have one with a stronger password for stuff that accounts that you rarely use. It works quite nicely. I'll show you the UI in a second. We've got deep tracing now, so there's a new API, trace underscore, part of the RPC. We've had some good positive feedback about this. You can get state deltas, a full VM trace, and what we call the deep transaction trace, where basically it will trace all of the calls that a transaction happens to have, including the ones that failed. So you can actually go all the way to the bottom of the call tree and see what happened to cause the failure. You can use it for previewing new transactions, but you can also rerun existing transactions on the blockchain. And you don't require any additional sort of we've actually got tracing as well, which allows you to do indexed tracing, so you can actually trace all transactions as they're executed on the blockchain and trace historical ones. But this allows you to rerun them and generate new traces. We've got Tendermint now built into the Parity release, the latest release. So yeah. So this is basically using our pluggable consensus engine. This is a proof of authority variant of Tendermint, so there's no proof of stake in this particular version, but we are adding a proof of stake variant to it. Basically, the authorities are controlled with a contract that exists on the blockchain itself, so those authorities can programmatically alter the authority set. And in doing so, we want to introduce a proof of stake contract, which is going to be able to allow public addresses to sort of become authorities by virtue of laying down stake. We've got Stratum integration right in the client, so that high-performance mining pools are able now to get effectively push requests for new workloads. We've got scheduled transactions now. So this is basically like an alarm clock feature, which was used to some degree in the recent Melonport crowd sale. Basically, you can log up transactions on your node and have the node published into the network when particular conditions are met. At the moment, there's only two conditions. A particular block height has been reached, or a particular block timestamp has been reached. But we're probably going to make that much more programmatic, so you can put in which conditions you want, probably based upon the outcome of particular message calls. So we've got auto-updating. The idea behind this is that node maintainers can automatically get updates from the network, so when we release a new version, it all kind of works. It's got a bunch of additional sort of niceties, though. You can set it always to on, never to update. You can update in the release track, so always update beta releases, always update stable releases, always update nightly releases. Or you can just stick to your minor version. So as if anyone's familiar, our Parity versioning system basically follows the Rust versioning system, whereby we have release tracks. And after about 7 weeks of being active, we move it from beta into stable, or from nightly or master or whatever into beta. We can make it so it's only critical stuff. So, for example, we may do a critical security update, and then you can make people who want to update only on a security updates update. We can also do consensus updates. So through the backing smart contract, we can determine whether a particular update or whether a particular version can stay up to date for a given fork of the network. This will come into play heavily if we come across a new issue with a network, or want to make a new fork, for example, the Metropolis. It's got the smart contract behind it has got, I'll go into this a bit later, but basically it's got a partially oriented multi-phase, multi-key system, which kind of just increases the security of the system as a whole. Basically, to make a release, it does actually require a cold wallet key to sign a transaction. We've been building a bit of infrastructure as well. We've been keeping not massively loud, we're kind of just sort of getting along and prototyping some stuff. We've got a name registry that's been active for a while. We've got a bunch of other sub-registries for registering tokens, dApps, and badges or certifications. These are all kind of built into the UI. We've got a URL hinter, which kind of is like a sort of not very good placeholder for more sort of decentralized lookup services. But basically, it allows you to get a URL from a particular hash, download something at the URL, check that it actually does hash to that thing, and then you've got the data. The three more interesting ones came out with the 1.5 release. Operations, SMS, and email verification. Operations is what powers the auto-update of Parity, but in principle it can do an awful lot more. Basically, it's meant to be a contract which chronicles the state of not just the Parity client, but in fact any client, all of the release tracks of those clients, and all of the binary versions of those releases. And then on top of that, it chronicles the different consensus versions of the network. So basically, the different forks of the network itself. So as a network new fork is released, different client teams can vote on that fork, and only when a sufficient number of client teams, or if veto rule is in place, the no client team vetoes it, does the fork become, as far as this contract is concerned, the official version. It's also given a block number, so it knows when this fork will take effect, and the client releases have to specify which fork they support, which means now auto-update contracts can determine whether the client that is currently running, i.e. themselves, are able to support a particular version of the protocol. And then they can also determine which is the lowest release on their track, which can support the current fork of the network, update to that, and restart themselves automatically, and hey presto, you've got a network which can automatically move forward in consensus. We've got a couple of centralized based services, SMS and email certification. Basically, the SMS certification is ideally is this tool to fight civil. It's centralized, unfortunately. We might look into doing something a bit more kind of interesting and decentralized, but for now it's there to fulfill a particular sort of use case. The idea is that accounts can get certified. They can tie themselves to an SMS, a phone number. It's super low cost. It's just the price that we pay for sending the SMS out back onto the network. No data is released on the chain. We keep a hash of the phone number, but that's it. And the idea is that this means that only the accounts that are certified with this, well, the accounts that are certified with this can be proved to be held by the owner of one mobile phone. Okay, if you buy multiple mobile phones, you can have multiple accounts, but it's unlikely you're going to buy 10,000 SIM cards and register them all. We also got the email certifier. This actually does store the hash of the email on the chain. What it basically means is that you can type in someone's email. If they've registered through the email certifier, you can be guaranteed that at least Parity thinks that, or Parity has had proof that this email belongs to this address. It will send your email a particular verification string. You then basically send that to a contract, and the contract will check to make sure it's what Parity sent off into the email, and if it is, it just assumes that you've got access to that email, and therefore this particular address lines up with this particular email. Type the email into Parity, and it will tell you which address it is. It's of course a contract, so any other clients can use it. I'll go through the wallet quickly. So Parity Wallet is the UI that we built for the Parity client. It does a whole bunch of stuff, identity management, transaction tracing. It also has a Chrome extension support now, so basically you can visit any website and it will auto-inject the Parity UI into the website. The identity management, yeah, it can display names. It looks up things in the DAP registry, the badge registry, the token registry, in order to display what tokens and badges the certifications a particular account has. You can put local tags on. There's a screenshot. You can see there's a few coins listed next to the original account. €5 from the decentralized capital guys. You can also see it's got an email verification, so that original account has actually been verified with my email. Create a new account, you can choose your little identigram. There's some of the vault stuff. Yeah, there's an example of an account page. That's me typing in an email, and it says yes, that's verified. You know, and it demonstrates that the email is really. There's stuff. There's more stuff. Yeah, you can make contracts in it. There's encoding. It's got a secure signer. This is like super designed over multiple tier framework, so that basically we keep secrets transiently in one particular process of the Parity node, so they don't touch JavaScript. There's no way JavaScript can even supply a password to the node unless it's operating in a secure environment. There's some screenshots of that. You can publish applications. There's some screenshots of the applications page. Blah blah blah. Yep. There you can view the transaction queue. That's very handy. Right. This is something I really wanted to go over, which I'll do quickly. There's docs. This is a alternative API to Web3. It's promise-based. It's super simple. There's some code example. This is an alternative to that, which is much at a higher level. There's a code example, as you can see. This uses a bonds API, which is basically an ongoing promise. So it's like a promise, except it subscribes as well. So if there's any updates to the underlying value, it will asynchronously update your code. In this case, what we're doing is every time the balance of the latest block's author changes, we'll get a console log. Yeah. This is a React library on top of that. What this does is it will render the balance of the latest block's author, and that will stay. That's reactive, so it will just stay updated. Yeah, super simple. Here it works with contracts. What this contract does is it gives. What this React component does is says you have, and then some amount of Gavcoin, and then also some amount of Ether. As you can see, the coin uses this make contract bond. Basically, makes a bond that represents the contract. It has all of the contract's calls in there, and the way it's doing it is by using the registry bond to get the Gavcoin address. It's all completely reactive. If the Gavcoin address changes, then the amount will change according to what's registered in the new token contract. If the default account changes, everything will change as well. It's like exactly as you expect it should work. There's another example. Which brings me to how many? 1 minute? 2 minutes. All right, 120 seconds. So Polkadot is a modular, scalable, mostly-ish, heterogeneous multi-chain. The idea is that you can have maybe hundreds, possibly 1,000 or so different chains. They're all working alongside each other. They're all parallelized, and they can send messages to each other. They can actually post messages to each other. It's less heavy than the guarantees Ethereum gives, whereby you can make calls and the calls come back synchronously. With Polkadot, all messages are asynchronous, so you just post them, you fire and forget. If you want a return route, you actually have to post the message back to the chain that originates it. But what it does is it allows us to have a very simple, or comparatively simple, architecture. Basically, the way it works is you've got pooled security, so the validators of all chains, they sit sort of in the middle. They get randomly chosen every round, every block. They validate a particular sort of parachain or subchains block that's been happily being processed in parallel. And then they eventually all come together and form a consensus over which of the subchain blocks will go forward in the next sort of super block. They give you trust-free transactions, and critically, it's entirely general. So it doesn't concentrate on tokens. In fact, it doesn't think about tokens at all. There isn't really tokens other than the staking tokens. So there's no set semantics. The guarantees in terms of which messages arrive at what endpoint are basically the same guarantees that Ethereum gives. If a contract sends a message, then it will arrive at its destination contract for sure. Of course, the semantics of what that contract does with it might, depending on the gas provider and all that sort of stuff, can be maybe different. How does it work? Well, you've got relay chain and parachains. The relay chain is basically the top-level chain that actually looks after relaying all the transactions between the sub-chains, the parachains. Parachains themselves are constituent chains, basically defined by a verification, validation function. This is entirely Turing complete, runs near native speed. We're probably going to use WASM for it. And the idea is that you can add new kinds of parachains onto the system as it's running. So in much the same way with Ethereum, you can code up new contracts. With Polkadot, you can code up new blockchains and just sort of tack them on. And those blockchains can use arbitrary sort of consensus mechanisms. They can even sort of not be really part of the system. They can be sort of bridge chains. So they could, in principle, look like a relay chain themselves, and then you've got this sort of composable hierarchical system of chains, which would, in fact, then come to lead to much greater potential scalability. They may be consortium chains. They may operate with their own validation system. It may just be that the main relay chain takes, rather than the validation function actually executing any transactions. Rather than that, what it does is it just checks the signatures of the validators to make sure that these particular validators did indeed vote for this particular chain at this particular time. In that sense, it could become then a bridge to other networks that want to keep their data hidden. That's about it. I think I'm probably just about on time.